Hello, AI enthusiast. Welcome to our brand new YouTube series, Building Generative AI Platforms. I am Sposh and I'm excited to take you on a deep dive into the fascinating world of generative AI. In this particular piece of series, we would be referring to one of the amazing blogs written by Chip Huan, who was a earlier undergrad graduate at Stanford, and then they worked as a professor teaching the course of machine learning system design at Stanford, and I've worked with a lot of ML initiatives. In this particular series, we are going to cover their blog that they have written, Building a Generative AI Platform. Believe me, it's a very beautiful and very interesting technical blog that I would be sharing as part of this series. And before diving deep, let's understand that we all know by now generative AI is transforming industries by creating content, optimizing process, generating art, and whatnot. And even some of the people have started to say the future is multi-agentic. Now, whether you're a developer, a data scientist, or just curious about AI, this series will break down various complex concepts of designing generative AI platforms into easy to understand segments. And in this series over the next few videos, we will explore everything from foundational concepts to advanced techniques. So let's take a quick look at what we would be covering in this particular segment. That is, we would be designing a generative AI platform. The picture that you can see in front of you, it seems to be like a very complex picture, but we would be designing this whole generative AI platform step by step in a very easy to advanced concept. And now, without further ado, let's start on this journey together and unlock the potential and the whole architecture of how we build a generative AI platform. So, if we try to have a higher level look, what's happening is the user gives a query that goes to cache. That cache then particularly with query goes to context construction, in which the all the related content from the databases is taken into consideration. Then all that context construction, the initial data, the user query, the cache, is fed into the input guardrails. Once this thing passes the input guardrails, then we go to the model gateway, which does the routing, generation, scoring. Once everything is generated, then it goes to the output guardrails for safety verification and seeing like whatever we have generated is according to the standards of what we wanted. And if that test is passed, then if we are using agents, we can have a write actions or we can return the final response to the user. And on top of that, we also have this logging, monitoring, and analytics for the whole system that we have, which is too much to understand in a minute. And we are going to break down this whole architecture and we are going to build it from the scratch. So I hope you are excited to understand how you can also design a system like this. So let's start with the very basic or very simple thing is when we start the context or the query that we have. So in this is particularly how a lot of people build or think about generative AI application is that is the user passes the query, they will pass the query to the model API. Model API could be OpenAI, Google, Gemini, Claude's Anthropic, Mistral, or anything. And that particular model API does some sort of generation based on the query, and finally it returns the generated response to the user. This is an example of a very basic, not even an app, but just an API call of how people build applications. However, why are we now making it complex? Like some people might question that we can do the generation part from here only. But if you want to have a better generation based on our different dynamic needs, then enhancing context input into the model that we have give the model access to the different data sources and tools for information gathering and giving a better generation. Then we also need to put in guardrails to protect our industries, systems, and the users that we have as part of our company or services. Then we have model router and gateway to support complex pipelines. And this could be thought in the sense of we could have a lot of different services, but how do we route each services to the right sets of components of the model or the services that we have for generation? And we need to add more security. Then finally, if we are doing all these sorts of things, the cost and the latency increases by a lot. And we need to optimize that because if we want to scale our applications, that optimization really makes a difference. And then finally, we need to put everything into a complex logic right actions to maximize our system capabilities, yet at the same time remembering how are we going to make that system powerful and do the right job for us. And then finally, once we are doing all those things, the observability, it also is also an important component which allows us to see through what's happening at different instances and helps us for monitoring and debugging and orchestration of our application. And then particularly, it's not something for deploying our AI applications or something. It's just what components we need to consider and how we can go and think about those designing those things. So let's start with the next thing. The first step is like if we just go high level, what all things we are going to study are divided into 5 to 6 steps. The first is we are going to enhance the context. Second is we are going to put in the guardrails. Third is we will add the model router and gateway. Fourth is we would try to reduce the latency with caching. And then finally we will add some complex logic and write actions how we can control those things and make our applications run in the right way. Finally, we can have a little bit of discussion about the different observability monitoring mechanics. Moving forward, the first step that we have is the enhancing the context. And by enhancing the context, as it is rightly understood by what enhancing context means, is a lot of times the model requires the right context to answer. For example, I will give you a very good example. Is like if the user has given the query, will Acme's fancy printer A300 print 100 pps? The model will be able to respond better if it's given the specifications of the fancy printer A300. However, if you don't have the answer, the model might give generic answer or it might hallucinate also. And so in that sense, the context construction is a very good way to improve the performance of the model or the model API that we are using. And if we try to build an analogy, try to consider the enhancing context or context construction for foundation models equivalent to feature engineering that we do in the classical machine learning models. And this serves a similar purpose that we are giving the model the necessary information to process the input. And this is how mostly how people talk about racks. Why people say racks are very good or are way better as compared to simple using the model. I assume that people know what RAG is and how a simple RAG is created, but just to give you a high level overview, RAG is retrieval augmented generation, in which it has two components. One is the retriever and second is the generator. The generator is similar to the language model, the model API that we have, and the retriever is kind of a similar to what we have search. For example, if you're querying on Google, the Google might shows you relevant results according to the search. Once you have those relevant results, you use that thing with the input query to generate your final output, that is retrieval. Then you augment that retrieval with the generation part. So if you can see now our whatever the flow that we had, in which what we had earlier was query, model API, and response. Now we have query, which goes into the retriever. Now retriever goes into the memory that we have or the search that we had, and it gets certain context that are relevant to the query. Now we pass the context plus the query to the model API for generation, and it gives a response in which it has using the right set of context. And now in retrieval, there are different sorts of retrieval methods that we can use. Generally, earlier for most of the models that we had, we used to use this term-based retrieval, in which, for example, if I search for the query transformer, it fetches all the documents containing this keyword. Now with this thing, it is a very easy, very fast, very cheap way of retrieving. But there is a con to it that it's not that good when you try to consider the context related to it. Now coming to the second type of retrieval, which is in use a lot used nowadays, that is the embedding based retrieval. So in this particularly, uh, mostly for embedding based retrieval, we use the vector search, in which all the data that we have is first converted into the vectors, vector embeddings, and in those vector embeddings, we try to build a retriever which search and retrieves through the vector embeddings, the data set that we have, database that we have. And in this, most famously, people use FAS, which is an open source. I think open source. I'm not sure, but mostly open source by Meta or Facebook. Then we have Google Scan, and a lot of people they also use this Pinecone and VV8, and there are a lot of other ones. But FAS is one of the very important ones. FAS and Pinecone. Now there are certain metrics which are used for embedding based retrieval and which we can use to differentiate between the retrieval techniques and how well our retriever is performing. So one is the recall that we have. The second is the query per second, the number of queries we can handle per second. And if we have an application that is a very high traffic application, then this particular factor becomes very crucial. The third is the build time, the time required to build the index. A lot of times, what our data keeps on for a lot of applications, the data keeps on iterating, and we need to have the updated data for our application to work properly. And in that particular scenario, the weightage to the build time parameter is very high. Then we have the index size. Now, for a smaller applications, it might not matter, but when we are scaling, the more we want to scale, the more we have to optimize on these particular parameters. And this works with almost everything: text, images, videos, audios, code, and mostly they also include SQL and everything. Now, what happens is for the different retrieval techniques that we have discussed, it's not like we have to use them thing independently. A lot of times, the advanced systems that we've built are ensemble systems, which use the term-based retrieval for retrieving through the large sets of documents, and then putting an embedding-based retrieval based on what were the results of the term-based retrieval. Uh, and I think one of the things what we do is, for example, this is what I explained earlier, is like what they are doing is kind of a hybrid search. In this, in a sequential pattern, they first use the term-based system that fetches candidates. Then we use a more expensive mechanism such as k-nearest neighbors to find these best of these candidates. And the second step in this is called re-ranking. A lot of times, if we want to build complex rank-based systems, we use this concept of re-ranking, and they just explain it with the help of a very easy to understand example. That is, given the term transformer, I fetch all the documents that contain the word transformer, whether it's an electric device, a neural architecture, or a movie. Then, on top of that, I use a vector search to find among those documents that are actually related to my transformer query. And context re-ranking that we have, it slightly differs from traditional search re-ranking. And in this context re-ranking, the exact position of the item is less critical. In search, generally, the first or the fifth, there's a major difference. The first is be very, very, very important as compared to the fifth. However, in context re-ranking, the order of documents matters, but it doesn't have that much effect. Generally, earlier what used to happen if the context of that particular problem was in the start, then we used to have better results as compared to it being in the later half of the document. And this thing has been very widely discussed nowadays with LLM. This problem is already discussed in almost all aspects is by the name of lost in the middle problem. However, as we have been putting more and more longer documents into the LLMs or the model context, the impact of its order is becoming less and less significant, and which is less significant at least as compared to the search ranking. And then you can build any sort of ensemble patterns on top of these different retrievers. Then we also can have racks with the tabular data, in which what happens is, based on the user query that we asked, based on the user query, the table schemas, we ask the model to write the SQL query for us. Then we execute that SQL query, and based on the SQL query that we have executed, we would have got some results. Now, based on the results in the SQL query and the initial user query, we try to feed in all the context and give our model API all the context to generate an answer in which the model API might directly give us a response. And a lot of times, while building racks, what people do is for tables, for all the tables that are there, they try to convert those document tables into SQL format or a data frame or JSON or easy to understand format for the retriever. And then when the user retrieves something from that particular table, then it knows what information is present in which table. Then for that particular table, it might use SQL or some another aspect. And then once it fetches those data, then it passes all those things to generator, and the generator gives us the right response. The next we have the other agentic racks, and it's similar to building an agent on top of the retrieval augmented systems that we have. And in this particularly, when we are building the retriever for the context construction, we might use normal retriever that we have from the databases, and we can also have some sort of an action which are done by agent. For example, I can have a search agent in which that agent has a search tool, and if it thinks that it should go to Google or DuckDuckGo to search for that particular query, then it can go and gather some of those results, which it will pass as which it will pass in appending to the what my retriever has given, and based on everything the context is constructed, and a model might be able to give a better results. And action versus tool. So most probably when we if you have tried to build like OpenAI assistant, Crew AI, or I think Microsoft AutoGen also, mostly the action that could have been taken by the different agents that we have, those are regarded as tools. So maybe we can use both of these terms interdependently. And there are two things when we come to agents, these are very important things. That is, the agents can have read-only actions and versus write actions. And believe me, when we are designing these applications for the real-world use cases, the write actions, we need to make them very safe. For example, if someone jailbreaks into my system and it asks my agent to drop all the tables in a DB. And if my agent has those right access, it can drop all the tables. So it's we have to be very sure about if we are giving right actions to the agents that we have, and we will see how we give these actions to the agents that we have. Then one more thing is query rewriting. What happens a lot of times, the user gives a query, but that's too vague for the model to understand. And if the model doesn't understand that query, it's going to hallucinate. For example, let's see this thing. The user asks, when was the last time? John Doe bought something from us. Then AI went to the database and it got everything. Now the user asks, how about Emily Doe? If the assistant or the chatbot or the language model we have, it doesn't have any context about it just sees how about Emily Doe without the context. It's very ambiguous. It might give anything. So what we do in these kind of scenarios, kind of rewrite the query as compared to what the conversation was going earlier. So for example, we can give some prompt like this. Given the following conversation, rewrite the last user input in fact to reflect what the user is really asking. And if we feed in all things, the model gives us the output. When was the last time Emily Doe bought something from us? And then which is going to give us right answer, which a much higher probability. So I think like this has been a very big session till now, and we would be covering the later segments of this session in the next aspect. So in this thing, we understand building a very simple AI application, then building racks, different kinds of retrievers in the racks, and then how we can enhance some of the properties of the racks that we have, and agents, then some of the tools, and then finally the query writing. So with this, I hope you got to understand a lot of things. And if you are still with us, please like, share, subscribe this particular session, and do let us know if you have any doubts. Thank you very much. See you in the next session.